So now we're going to learn about the parallax method. Alright? Well, parallax is something very easy to see and to notice. And I am absolutely sure you have noticed it earlier in your life, just that the name is new. Okay, you didn't know the name, now you know the name. Okay, put your finger in front of your eyes like this. Come on, don't be shy. Do you realize that you can shift your view if you see from this eye and from that eye? Can you do that? I don't know how better to describe it. No? See, for example, if I see it with my right eye, the finger is here. But if I see it with my left eye, the finger is here. It appears to have shifted. Can you do that, or is it tough? You can try, it's okay. Who managed to do it? Does it appear to have shifted if you just change your eye? The eye by which you are seeing. You can close your eye if you want, that also helps. Okay, I hope you will not be hesitant. Okay? Fine, let me put another question in front of you. There's a blue pen, there's a black pen. Alright, so I'm going to ask one of you this question. Which pen is on the left side? Okay, according to you. Alright, when I ask a particular person, you will tell me which pen appears to be on the left side. Okay, so here are the two pens. What's your name? Please stand up, please. Which pen is on the left side? Red pen. Awesome. Black pen. Alright, black pen. Alright, very good. Thank you so much. Sit down. Now, you are the second pen. What's your name?
Vishwa.
Is it that pen? Sorry?
Vishwa.
Which one? Okay, which one? See, I have not changed anything, right?
Yes.
Which pen is on the left side? Blue pen. Okay. Strange. Is it it? Which pen is on the left side?
Black and blue. Both.
So, what she did actually teaches you a lot about parallax. Did you see that first she tilted this way, she had one answer, and then she tilted that way, she had another answer. Yes or no? So, I'm sure all the girls over here will say that the blue pen is on the left. Yes or no?
Yes.
Does the blue pen appear on the left side of the black pen? Correct or not correct?
Yes.
Sure?
Yes.
4 people over here in this line, and I'm trying to keep both these pens on the same line. So neither one of them is on left and neither one of them is on right. But everybody on this side is going to say that the black pen is on the left. Yes or no? Yes. What's the magic here? Who is right? Sit down. Who is right? Everyone is right. It's all different viewpoints. Same thing here. If you put your finger and you watch it from this side, this finger appears to be in this direction. Then if you change the eye, it appears to be in a different direction. Yes or no? Did you notice that? Try it again if you did it earlier. I really suggest, because that is what parallax is. If you don't understand what happens with the finger, you will not understand what is parallax. Try it. I'm giving you a minute again. Okay, if you didn't see it earlier, give it a try now. You don't have to move your finger, of course. If you just shift your eye, the finger appears to have moved, but the background will remain same. Yes or no? Did you also notice that? So you real that's my game. Did you understand?
Yes.
Sure.
Yes.
So what is parallax and how do we measure large distances using parallax? First of all, parallax means that when you don't need to write the definition. When different objects are seen from different viewpoints. You understand this word? What do you think of viewpoint? One time from here, another time from there. When different objects are seen from different viewpoints. Do you remember line of sight? Line of sight. 10 standard maths. Height and distances. Line of sight. Yes, there were some regarding line of sight. It would be something like line of sight makes an angle of 30 degree with the horizontal. Anyone recollect this? Yes. Okay, I hope that portion was not omitted. I mean, sorry, omitted, not omitted. Omitted from your syllabus. Right? So when different objects are seen from different viewpoints, their relative positions appear different. This is what is parallax. Okay, this thing is called parallax. And we will use that to find large distance. How? Okay, would you say sun is close to the earth or far from the earth? Far. Compared to the other object that we are seeing here, sun is far. Sure? Absolutely. Which is closer, your home or sun? Thank you. Have you noted that when you walk and let's say the sun is there or the moon is there, it appears to come with you? How many of you have noted? Sure, we have seen it. If you have not seen it, I recommend, I suggest that tonight you go home, okay, and if the moon is out, it will probably be, and hopefully you can see it if there are no clouds. Okay, take a walk. You realize that as you walk, the moon seems to come with you. Don't look at the sun. It's harmful to your eye. Alright? Okay, that's why I didn't say sun. Good. What is that? It's telling you that when the objects are very far away objects, they appear to shift. They appear to shift along with you. Right? As you move, they appear to move. Correct or not? This is, of course, due to parallax. Let's see how we use it. Now, a lot of things that we have learned earlier are going to be used now. This is, let's say, Earth. So this is Earth. Right? Figure not to scale. Right? And here is, suppose, Jupiter. I know Jupiter is not that small. It's very big, but considering that it's quite far, it appears to be small. Got it? So here's Jupiter. And one person, one observer on Earth. Here is one observer on Earth. Why is the observer at an angle? No, the observer is standing properly. I hope you realize that. Because Earth is a sphere. Clear or not clear? Yes. So this observer is observing or seeing Jupiter. And let's say that this observer observes that Jupiter appears to be in line just with some star which is very far. I'm sure you all have basic knowledge that planets are within the solar system. They are close to us comparatively. And the stars, other stars that we see in the night sky, they are all very, very far. Yes or no? Everyone is aware of this? Sure? Okay. So the situation is just like when you take a walk, the houses around you, they seem to go back, they seem to move, but the sun seems to come with you, or the moon seems to come with you, because moon is quite far compared to the houses or trees. Yes or no? This guy is observing Jupiter, let's say, and observe that some star is right in line with Jupiter. Oh, very good. At the same time, let's say this observer A. At the same time, suppose there is another observer B at some other place on Earth. At the same time, suppose there is another observer B. Okay? At some other place on Earth. And that person observes Jupiter and that star. But because this star is very far, can you imagine that? Suppose this person could run very far. So when this person will run and reach here, the star would have appeared to move with him. Yes or no? Did you understand this line? No. This is what I was saying. Think of the sun. You walk. Doesn't sun appear to come with you? No? So, I've told you. If you look for physics inside textbook, it's not going to work. Physics is out there in nature. The more you observe, the more you are going to understand. You can try. Let's do it practically. He said no. Stand up. What's your name? Jay, come here. Let's make him do it practically, okay? And he is going to be a representative. Okay. Have a look at things over there. Alright, and look at this gray in the window. Right? You can pick some solar panels over there. There are so many. Correct or not? Now try to walk. What did you see? Green appears to move back, but solar panel comes with it. Did you see that? Sure, you did. I'm not forcing you. Concept clear? Thank you. Again, have you been on trains ever in your life? Have you ever been on a train? When train moves, have you noted that things that are far away, they just seem to come with you? Yes or no?
Yes.
Sure. Compared to the things that are closer. The things closer, they seem to go back. But the things that are way far, they seem to come with you. Just like sun seems to come with you when you walk. Just like moon, it seems to come with you when you walk. That's parallel. It's basically the same thing happening. One time you watch from here, one time you watch from here. The background appears to remain the same. But it's just that it appears that this has moved. So for this person, let's say this person runs and goes in there. The star which is very, very far, it will still appear to come with that person. That is, let's say this is you. You start running. So just like sun appears to come with you. Okay, sun is here, fine. Just like that, this star will just remain there. So even when you go there, star will appear to be in this direction. But comparatively, Jupiter is close. So now if you want to see Jupiter, you'll have to see in this direction. Yes or no? But star will be in that direction. Yes or no? These are two parallel lines. You get what I'm saying? These are two parallel lines. This angle, suppose theta. This angle will also be theta. I hope you get that. What are such angles called? Alternate angles on two sides of transverse. Alright, alternate angles made by transverse. Okay, alternate angles for short. Okay, okay or not okay? Fine. Do you see a triangle somewhere? Yes or no?
Yes.
Let's look at that one. I hope you are noting things. I will not give you time at the end. Okay, I am explaining very slowly. Look at it. I have started. I wrote this sentence. It's been more than 10 minutes. And we are still here. So I am giving you time to write as I teach you. At the end, I will erase it. I will not give you time at that moment. Okay, so make sure you are noting as I write. In my class, you are allowed to note as I teach. Okay, you have to learn to focus at both the places. On the board and also in your. To be very frank, I am not convinced that you are convinced about this. Right? How many of you are convinced about this? What I have drawn here? You can be honest, it's okay. There is no pressure, like I have said. Very good. And I believe others are not convinced. I know you are thinking that if you change your location, don't you have to look at in a different direction? Is that what you are thinking? Pen is here. If you move the pen, don't you have to look in a different direction? That's what you are thinking? That's the difference. Pen is at 1 foot from mine. This star is millions of kilometers away. So is the sun. You should definitely try it. It will be very good if you try this today. What to do? Just like I told you to do. Look at objects. Pick one object that is close to you and pick one object that is far. start to walk, you will realize that the object that is far is moving with you, and the object close to you seems to go back. Alright? So this is what parallax is about. We have got this angle theta. Okay. Then suppose Jupiter is at a distance d from Earth. This is d. You understand what is d? D is distance of Jupiter from the observer from Earth. Correct? Clear or not clear? Okay. This line, it looks like base of the triangle. Yes or no? I am sure you understand what is meaning of base of a triangle. Correct? Base of triangle is clear to you? Yes or no?
Yes.
Now, so the idea is as follows. In this triangle, theta is measured experimentally. Theta is measured experimentally. That is by doing an experiment. Also, anyone has a protractor right now with them? Protractor, anyone? Normally, I've told you that you don't need tools, but today, if you have it, we can use it. Anyone has a protractor? That's called a compass. The one with which you measure angles, yeah. Thank you. Okay. I know what you call it. Protractor. Okay. So I'm saying that how do we measure this? It's like for one person, okay, for this person, right? Let's say this person is working to the sky. Just an imaginative world, okay, I'm the rocker. You have to use telescope. Anyways, so you watch it, okay, right? Jupiter and star both are in the same direction. Very good. Now for this person, what will this person do? This person will point the telescope to the sky and see, okay, right? Star is here, and Jupiter is here. Between these two, how much is the angle? You try to draw and put a protractor and see, okay, right, 1 degree. Understood? So by measurement, this person said, right, Jupiter is over there. This person said, well, that star is over there, right? So measures the angle between them. Can they say, I'm good. Suppose mantra is from here, mantra is let's say 10 degrees that way. Alright? And from here the door is let's say 30 degrees that way. So we can say that angle between mantra and the door is 40 degrees. Did you understand? 10 this way, 30 that way. So how much total angle? 40. Got it? Like that. From here to there. Like that. Okay. So just like this it is measured. Jupiter, star, we measured it. Get it done. So this is theta. So theta is measured experimentally. Now, what about B? B is actually distance between 2 points on Earth. B is distance between 2 points on Earth. Don't you think we know the distance between 2 points on Earth? In every case, suppose someone will ask you what's the distance between here. Let's say Ahmedabad. Suppose one person is observing from here and one person is observing from Ahmedabad. How much will be the distance between the two places? We know that. Nearly how much? 120 kilometers. Yes or no? Probably a little bit less if you go straight through it. Clear or not clear? Yes. Sure. So we already know B. What is B? Distance between DIST is sort of distance, BD is sort of between. Distance between two places of observation. Distance between two places of observation. That is, you observe from here, you observe from there. Right? Often it is diameter. You know the way I have drawn it. Often people take it as diameter of Earth. You know, Earth is like what? Sphere. Alright? Similar to a sphere, not exactly a sphere, but anyway. So it's similar to a sphere, that's why we can take it diameter. But you can take any other distance, not necessarily diameter. It can be less than that. Okay, so this is what we do. If we put theta value and P's value, we can get D's value. How? Okay. Do you remember that in small angle approximations, I have taught you that if you have got a circle, this is a circle, alright? And this part is the R, yes or no? But the chord is B. I hope you understood what I am saying. arc is not B, the chord is B. Clear? Clear or not clear?
Yes, sir.
I told you that when the angle is small, the chord and the arc, they are equal in length. Yes or no? You can refer to your notes from earlier. Remember that length of chord and length of arc will be nearly equal for what? For small. Is it there? Is it there in your notebook, everyone? I'm asking you. Is this thing mentioned anywhere in your notebook? Check it. Did you write it?
Yes, sir.
Is it there? No. Not there?
Sounds good. Your name is
Sums are only there. What about the things that I write on the board, I teach you? What about that? You are not making notes of that? Huh? I'm talking about online lectures so far. You have had so many online lectures so far, haven't we? I hope you have noted things down. Do you remember this?
Yes.
If आनु meaning आनु होता है AB is 40, isn't it? And RAB. Yes or no?
Yes, sir.
Okay, did you find this in your notebook? Who found this in their notebook? Raise your hand, please. Who found this in their notebook? Sure, it's there. I made you write that.
Yes, sir.
Very good. Didn't I tell you earlier that science in 11th and 12th, everything, one topic leads to next topic. If you are absent one day, next day you are going to just stare. Okay, what's going on? I don't know. So, for small angle, we can use this. Now, is this a small angle? Simple question. Is this theta going to be small? Well, yes, it's going to be very, very small. It's going to be very, very small. Let me take an example. Suppose here is one point, here is another point. Let's say distance between them is 1 meter. And here we have another point, and this distance is also 1 meter, and this distance is also 1 meter. Then what will be the angles? This is a triangle, yes or no? What are the angles? Can you tell me the angles of this triangle? 1 meter, 1 meter, 1 meter. Which kind of triangle? Equilateral triangle. Okay, who can tell me angles of the equilateral triangle? Raise your hand. What are the angles of an equilateral triangle? Question is no one. Equilateral triangle, the angles are, yes, 6 degree. Which one is 6 degree? All of them are 6 degree. Alright, very good. What's your name?
Risha.
Okay. So all of them are 6 degree. Very good. Clear? Fine. Let's change things a little. Suppose instead of this being 1 meter only, let's say I take a point which is far. What do you think would have happened now? Would this angle still be 60 degrees? Would it be less? Would it be more? Triangle of Keto. What would happen to this angle? Would it become smaller than 60 or greater than 60? Smaller. Everyone gets there? You can try it. You can draw two triangles. See, 1 second. Which angle is more? First one or second one? First one is more. Second one is less. So, like I said, suppose we made this 2 meters. Fine. Now, let's make it 100 meters. So, what would the triangle look like? Well, it would look something like this. Yes or no? Look at this angle. Small or big?
Small.
Okay, is Jupiter 100 meters away? I'm not talking about your scooter. I'm talking about Jupiter planet. Is that planet 100 meters away? How far is it? Much more than this. Yes or no? Can you imagine what the triangle would look like if Jupiter is very, very, very far? Would it be even this big an angle? Think about it. Here I have just taken this to be about 5 centimeters, and this looks like 1 meter. But now we are talking about thousands of kilometers. Yes or no? So would this angle be small?
Yes, sir.
Yes, very, very, very small. So for small angle, can we do this? That arc length and chord length, they are nearly equal, approximately equal. Understood? Fine. So I hope now it's clear to you that whenever we are talking about astronomy, this distance, this angle has to be very, very small. Don't go by the triangle drawn here. This distance will be very. So, do you realize that arc length? Okay, we are continuing from there. You can put 2 points here: A, B, and let's say this is J. J for Jupiter. Right? So arc length, that is AB, will be nearly equal to chord length AB. Alright? Is this fine, everyone? Once and for the last time. Now, do you remember a formula of arc length that I have taught you? How to find arc of circle? Length of arc of circle. Come on. That many of you knew it. So I'm confident that today you will be able to give me the right answer. Length of arc. Formula pi r theta upon 1/8. That's the formula you have learned in 10th standard. Where theta is in which unit? Degree unit. Do you remember I mentioned that in the class? But we use SI unit, and SI unit is radian. So if you want to do it in radian, then what's the formula of arc length? I equal to r theta. This is what is lacking everyone. This is not a good sign. Was it taught earlier? Yes. Should you be able to answer it today? Absolutely. नहीं आवड़े तो શું થશે? नहीं आवड़े तो શું થશે? તો સવારે કઈ કીધું છે ને? Clear? So tomorrow I want everything that you have learned to be clear. Is it fine? I'm going to ask you everything that I have taught you so far. Milli, micro, mega, blah blah blah, everything. Okay, there the 7 fundamental quantities, there are 7 units. Do you remember those? The short form I told you, ATM, 10. Do you remember that or not?
Yes, sir.
Everything clear? Yes?
Yes.
No. I'm not asking anyone to write it at the moment. I'm giving you time. If you cannot prepare it by tomorrow, be ready. You are going to have to write. Okay? Is instruction clear? What did I ask you? Whatever we have learned so far in chapter 2, prefixes, units, those 10 dimensions. Do you remember those 10 dimensions of velocity, acceleration, force, and all those? All that was not taught just for type 1. Let me be very clear. Are we going to use it again and again? Absolutely. Like here, are we going to use the arc length formula that I have taught you? Yes, of course. That's why I taught you. I should mention I am very lazy. નકામી કોઈ વસ્તુ હું બોલીશ નહીં અને નકામી કોઈ વસ્તુ તમને લખાવી. Got it? Is that clear? So L is equal to R theta. Do you remember that? Yes or no?
Yes, sir.
Sure. L is equal to R theta. But here the chord length is BE and arc length we have formed. So do you agree that I should write it like this? What's the arc length? What's the arc length? R theta. What's the chord length? Look at the triangle. B. Yes or no? Okay, but here the radius of this circle. Look at this diagram. It looks like here the circle. What is the radius of the circle? Look at that diagram. What is the radius of the circle? AJ. Yes or no? How much is AJ? D. Is it? D clear? Sure?
Yes.
That's right then. So instead of writing R as radius of circle, if I write D into theta is equal to B, then I get D is equal to this is the formula for parallax method to measure large distance. The distance between, for example, here Earth and Jupiter. How much is it? It is B divided by theta. What is B? B is called the base of this triangle, called basis sometimes. Okay, that you observe from here, the distance between them, that is called B. And when you observe it and you are measuring the angle of parallax, right, this parallax occurs. Here, this guy says that star and Jupiter are on the same line. But this guy says that no, star is here, Jupiter is here, there is some angle between them. That's called what? Parallax. Okay, so that angle is theta. See, it's as simple as this. When I did put the pens like this, didn't these people say that these pens are on the same line? So they are like observer A. Have a look. They are saying that, what are they saying? The pens are on same line. Yes or no?
Yes.
Sure. But now when someone else observes it, here or from here, what do they see? What do they see? Are these two in the same line? No. They see an angle between them. Correct or not? Yes or no?
Yes.
Where's an angle in this diagram? Absolutely clear what's going on here. Still, I have told you, without doing that practically, you will not understand. So make sure you do this at home today. Okay, give it a try. So this is the formula for using parallax method to measure large distances. Okay, that's all questions. You want time to note it? This is the last time you are going to get time to note. Alright? 1 minute. That's it. Note down whatever you want. Is remembering only formula enough? No. That won't help. You should understand how it is used. You can also make that triangle and write down the names. For example, B stands for basis, for base. Theta stands for parallax angle. Parallax angle is the angle that we measure by this method. Okay? And D, actually B is the distance between, like I've written out there, I don't want to repeat. Okay? And D stands for the required astronomical distance. The required astronomical distance. That's how it's working. Okay. Example. Example 2.1 is homework. Example 2.1 is homework. Why am I asking you to do it as homework? If you read the question, you will understand. It's all about degree, minute, second. Do you remember degree, minute, seconds, everyone?
Yes.
We converted the units. Yes or no?
Yes.
Sure we did?
Yes.
It's about that. Okay, you have already solved 10 such questions. These are just 3 more. Okay, and that too very easy. Almost all was discussed in the class. Okay. Next. 2.2 we are not going to do it. Okay. I'm making it very clear. We will not do 2.2. Why? Please don't think that I don't know. Right? Method of parallax is actually, read the title if you have the book with you. 2.3.1. What is it? Measurement of large distance. Okay, so parallax method is only useful for worth doing. If you want to measure such distances which you cannot measure by any other means. Can you put a ruler between Earth and Jupiter and find out how much is the distance? Surely not. You get what I am saying? Yes or no? It's impossible to do that. So, only to measure such large distances we use parallax method. Here in 2.2, we are given a simple method to find out the distance between a tower or something. Okay, you're free to do it, try it if you want. I don't think it is worthy of discussion in the class. Alright, if you try it, if you get stuck, if you don't know the answer, definitely come to me. I will help you. Okay, now Example 2.3. The moon is observed from two diametrically opposite points A and B on Earth. Very good. I don't have to draw new diagram. The moon is observed from two diametrically opposite points on Earth. Diametrically opposite means on two sides of a diameter. Is it clear?
Yes.
The angle theta subtended at the moon by the two directions of observation is how much? 1 degree and 54 seconds. 1 degree 54 minutes. Clear? 1 degree and 54 minutes. Right? So we are given which value? It's not Jupiter anymore. What is it? What is it? Moon. M. And theta's value is given in the question. How much is theta's value? 1 degree and 54 minutes. Okay? So I'm just making a little list here. For example, 2.3. Theta is given 1 degree 54 minutes. Can you convert it to minutes? 140 minutes. 1/4. Why 1/4? 60. 1 degree is how many minutes? 60 plus 54. 1/4. Is that clear?
Yes, sir.
We did a question like this before. Okay. Who understood this? Raise your hands. Sure. Okay, put your hand up. Do you have roll numbers already? Yes, I guess so. Yes or no?
Yes,
Who is the first roll number in your class? What's your roll number? 41. Oh, fine, sit down. So, I'm just going to ask this to one person. Let's say roll number 53. Okay, Prisha, what is if you convert 1 degree and no, let's say 2 degrees and 17 minutes to minutes. Can you convert this to minutes? 2 degrees 17 minutes. How many minutes?
137.
Sorry?
237.
237.
137.
137. How is it 137? Can you please explain your method?
1 degree is 60 minutes.
Yeah.
The 2 degrees 120 minutes.
Very
So
good.
120 plus 70.
Very good. Well done. Sit down. Yeah, this is the answer that I expected. Easy or not?
Yes.
Okay, so keep the basics clear and things are going to be simple. Okay, theta is given. Now, given the diameter of Earth, look at this diagram. What is diameter of Earth given in question? B. B, yes or no?
Yes.
Not capital D. Look at this triangle. Which quantity represents diameter of Earth? D or B? B. How much is B? 1.276. It can reach to 7. It is scientific notation. What is the suppose also 1.276.000.00. How many zeros? Okay, bad. Clear, right in scientific notation. Compute means calculate. What to calculate? What to calculate? Distance of moon from Earth. Did you understand how you should do it? How to do it? D equal to B upon theta. Yeah. Is that okay? I know the angle is not very small, but still fine. No problem. Up to 2-3 degrees, it's safe. It doesn't get that wrong. Okay. There'll be only a little bit of error. Little bit. Okay. Fine. Calculate it. Come on. You have two options. You can either do it in a calculator or without it. If your goal is neat, don't touch a calculator. But yeah, is diagram necessary? Yes. You have to draw it again for that example. Come on, everyone. Draw the diagram. Draw the diagram, everyone, for this example. You cannot recycle diagram unlike me. Okay? You are supposed to draw them every time. Just draw a triangle and then Earth. It's enough. Let me see what you are going to do. minute. अरे बॉम्ब फोड़ो जी फिजिक्स ગમતું નથી એટલે બોમ્બ ફોડ્યો basically type this diagram. So we go home and then write it again, and we do that every day. It takes good time. Okay, let's make one more to write everything with this. Okay, everyone, you just needed to draw the triangle. That's all we are interested in for this question. Done? I see nobody is using calculator. Does it mean you don't want to use it, or does it mean that you didn't bring it? Which option? First one or second one? Second one. Okay. એટલે ઈ તો બધાને યાદ છે ને કે ગુજસેટ થી ખાલી ફાર્મસી સિવાય તો ક્યાંય મળવાનું જ નથી એડમિટર. I hope that is clear or not clear. Everyone look over here. Is it clear to you that Gujarat can only give admission to pharmacy and nothing else? બધા ફાર્મસી માં લેવાનું છે બીજામાં લેવાનું જ ને ટ્રાય તો કરવાની જ ને મળે ન મળે તો અલગ વાત. Are you going to try? Oh, so keep that in mind. Right value of theta. What is SI unit of angle? Radian. So you have to convert minute to radian. Yes or no? Okay. I think very likely that you all will run out of time if I let you do. Let's see. So we are going to use the formula D equals D by theta. D is the basis which is given in the question, 1.276 into 10 raised to 7 divided by theta is 114 minute. But minute is not the SI unit. What is the SI unit? Radian. How to convert minute to radian? Do you remember? First convert minute to degree. 1 minute for converting minute to degree, what should you do? How many minutes is 1 degree? 60. So divide by 60. So now this is in degree. Is that clear or not? Just like how to convert minute to hour. Divide by 60. Yes or no?
Yes, sir.
Sure?
Yes.
Okay. Minute to hour divided by 60. So this is in degree. Now how to convert degree to radian? 1 degree is how many radian? 180 radian. 1 degree is 180 radian. 180 by 5 radian. 1 degree is 180 by 5 radian. 1 radian is 180 by 5 degree. Is that clear? So 5 radian is 180 degree and 5 by 180 radian is 1 degree. Is this clear? Yes. Clear or not clear?
Yes, sir.
I multiplied 5 here, then I divided 180 here. Understood? Understood or not?
Yes, sir.
Okay. So 5 by 180 radian is 1 degree. So if this is in degree, I have to multiply by 5 divided by 1. Get that? Or not? This is now in radian. Now we have to simplify all this. So 1.276 into 60 into 180 upon 114 into 5 into 10 raised to 7. This is going to be right. You know what people do? Often people don't want to do all this calculation. No problem. Look at the previous example, that is 2.1. Look at 2.1. Do you see they have converted 1 degree into radian in 2.1 example? Yes or no? Did you see it? I'm giving you permission to see its solution. So 1 degree is how many radian? 1.745 to 10 raised to minus 2 radian. You can mark it, you can try to remember if you don't want to do all these calculations. Done. Memorize it like a formula if you want to save your time. Second. Okay. Second will be about 1 minute. 1 minute is how many radian? 2.91 into 10 raised to minus 4 radian. Got it? How do we get that? We have already seen the method earlier. I am not going to repeat. We have learned how to convert. Yes or no? Have we learned or have we not learned? Have we learned or have we not learned? Not learned? અરે ઓલો C part હતો ને homework માં કર્યો છે કે નહીં? A, B and D. One day you did A, B and D and then you did C. What was C about? For all this. Correct or not? Okay. So that's the second one. You can remember that also if you want to save time. And then similarly the third one. About converting 1 second into radian. Otherwise you'll have to put up with this calculation. Okay, I'm leaving it here. At home you can do the calculation yourself however you want. Either with calculator or without calculator, the choice is yours. Okay? But again, like I said, the more you use the calculator, the more lazy you are going to get. In 10 you were not using calculator, am I right? You use multiply, divide, whatever comes your way. Yes or no? Easier. Fine. Now, time to give you homework. I think, fine, I'll give you some later. Actually. You already have plenty to worry about, isn't it? Lots of things to revise and remember by tomorrow. And make sure you do. Goodbye, everyone.